Hello and welcome to another PowerMaths lesson. Today we're going to be focusing on using different representations to find the missing number in a problem. Let's get started. You know what time it is? It's time for our Flashback 4. Have a go at this starter and then click pause when you're ready to go through your answers. Ready to check then? Okay, question 1. Complete the directions. It was move forward 2 squares, turn right, and then move forward 1 square. Second question, complete the sentence. The rectangle is to the left of the circle. Question 3, what is 3/4 of 8? And the answer is 6. If you know that 1/4 of 8 is 2, then 3/4 is 6, because 2 times 3 is 6. And question 4, write the number 62 in numerals. This is the other way around from yesterday, and there you go, there is the number 62. If you weren't quite sure what numerals means, numerals just means in numbers rather than words. Let's leave it there and move on to today's Power Maths. Here's today's Discover. It's called Missing Numbers. Now in today's Discover, it's Marta's birthday. And you can see that she's saying, now I have £55 altogether. Pay special attention to that word altogether. You can see that her father is giving her a £20 note. So it's interesting that now she has £55 altogether. Question 1 says this. How much money did Marta have before her father gave her £20? And it's given you a calculation there to represent that. Part B. Marta wants to donate £100 to charity, to a charity that protects birds. How much more does she need to save? So things to consider as you have a go at this Discover. Can you draw something to help you? What representations of the problem could you draw that you've already looked at this year in year 2? What could you draw to help you? And what calculation do you need to do to work out the answer? So have a go at the Discover, click pause now, and then click play when you want to share ideas together. Hopefully you've had a go at that Discover. Let's think about our WALT and our WILF for today and share some ideas about these questions. So our WALT today, to use representations and the inverse operation to solve problems. All that means is to be able to draw things out in different ways and to be able to know that for an addition calculation, we can also think about a subtraction and the other way around as well. And there's 3 steps we're going to be looking at today. We need to understand the missing number that we're looking for, and then we need to represent the problem with a drawing, and then we need to find the answer. Let's think back to that first question then. We were asked, how much money did Marta have before her father gave her £20? Let's have a look what Dexter's saying. He says, I know one part is 20, and the whole, that means the amount altogether, is 55. And I need to work out the missing part. To find a part, I can do a subtraction. 55 take away 20 equals my missing number. So have a look. That's been represented as a part-whole model. Here's your whole. That's how much Marta has altogether. Here's how much her father gave her. And this then must be how much she had before, because these 2 parts add up to make 55. Have a look at the other ways that you can represent that. As well as a part-whole model, you can represent it as a bar model. It's showing the same thing. 55 is the total, and 35 and 20 are the 2 parts. You can see here that it's been worked out. 35 is the other part that we needed. So this is how much she had before her father gave her £20. And again, the same thing is being shown here with the 10s and 1s. You can see that her father gave her 20. She has 55 altogether now. And so all you needed to work out was how many more 10s and 1s do you need to add to 20 to get to 55. And this was what Flo suggested you could draw to help you. And lastly, there's one more representation that you could have used. You could have used a number line. Started on 55, taken away the 20 that her father gave her, and seen what you had left. And you would have got to 35. So 55 is the same as £20 and £35. Marta had £35 before her father gave her £20. Notice that there are 2 calculations that have been used to represent this problem. 55 take away 20 equals the missing number, and 55 equals 20 add 35. Both a subtraction and an addition can be used to represent this problem. Let's think back to part B then. Part B asked Martha wants to donate £100 to a charity that protects birds. How much more does she need to save? And you can see here that it was represented with this calculation. 55, that's what Martha has now. She's got to get to 100, and we're finding out how much more she needs to add on to what she's already got to get 100. Again, let's have a look at the representations that have been used. This time, the 55 is what Martha's got at the moment, and she's looking to get some more. So the 55 is now a part, and 100 is the total that we're trying to get to, or the whole. And we're looking for this missing part here. You can see that drawing it out like this makes it really clear what we're looking for. And again, the same thing has been drawn with these representations. 100 is the whole that we're looking for. 55 is one of the parts, and we're looking for the other part. The other part is in fact 45. She needs 45 more pounds to get to 100. You can think of it as 55 add 45 equals 100, but to work it out, you're probably better off thinking about it as 100 take away 55 gets you to 45. Or even 100 take away something would get you to 55. And that's what's been shown on the number line. Starting at the total we're trying to get to, 100, and seeing what the difference is between 100 and 55. By counting back 40 and 5, you got from 100 to 55. So 55 and 45 is the same as 100. Martha needs to save another £45. Now that might feel like quite a lot. And when you're answering a question, you don't need to draw out all of these different representations. Whatever you need to use to help you understand the problem is best for you. Let's think together then. I'll talk you through question 1 and then you can do question 2 by yourself. Question 1 says this. A box holds 40 cups. There are 18 cups on the table. How many more cups are needed to fill the box? Let's have a look one by one at the calculations and the representations that are being used to show this problem. We know that our total amount is 40 cups. That's the maximum amount that a box can hold. So that is our whole. There are 18 cups on the table, and we need to know how many more to fill up to 40. So we're looking at this calculation. 18 cups on the table, add some cups, we don't know how many yet, we'll get to 40 cups. Or we can think about it like this. If we have space for 40 cups, we take away 18 that we've already filled. How many are we going to have left that we would need to fill the box? This time, the calculation hasn't been worked out for us. We need to know 18 add what equals 40. And all of these three representations are showing that problem. 18 is one part, and we've got a missing part until we get 40. The number line could help us work that out. By doing 40, take away 18, we would find our missing part. So have a look what's been done. 40, take away 10, that gets us to 30, and then take away 8 more gets us to 22. We've taken away 18 altogether, and we've got to 22, which means our missing part is 22. This is what all these representations look like completed. 18 add 22 is 40. 40 take away 18 is 22. Here are the two parts. There's the whole. Here are the two parts. There's the whole. And here are the two parts. There's the whole. In question 2, you're going to have a go at using the same representations. But I'll remind you, when you're doing your own working out, you don't have to draw out every representation to help you have a go at the problem. The things to consider are this. What are you trying to find out? How are you going to represent the problem? And also think about how you can check your answer. So, time for you to have a go. Question 2. A muffin costs 68p. Joe only has 38p. How much more does he need to buy a muffin? Have a look at those representations. Choose the ones that you're going to draw out to help you, or have a go at all of them if you'd like. Click pause there, have a go at answering the question, and then click play when you're ready to check your answer. Have you had a go? Let's think about the answer. To start off with, let's see how we can represent the problem. The muffin costs 68p altogether, and Joe has got 38p, so that's one of the parts. You can see that our calculation then becomes 38 add something equals 68. Or we can show it in a bar model or a part whole model. And we're looking for this missing part, which is 30. 38 add 30 equals 68. And you can see we've filled out the part whole model. You may have also chosen to think about it on a number line and started with 68, taken away 38, and you would have got to 30. That's another way you could have worked out the missing part. Let's have a go at the challenge, and then it'll be off to the practice books to give this some more practice. Our challenge today: find the value of the star and complete the series of calculations. Have a look what flows say. I can use one fact to find many more. Think about that. Earlier on in the week, we were practicing using what we already knew to answer the next question. You might be able to do that in this challenge. So think about what number facts you already know and think about working systematically. Remember, you can use a part whole model and any of the other representations you need to help you. Have a go at the challenge and then click play when you want to check your answer. Let's talk about this challenge then. The first thing we had to do was find the value of the star. And we had this calculation here. 22 add the star equals 56. Well, this is just the same as the missing number problems we've already been doing today. 22 add something equals 56. Let's have a look how that's represented in a part whole model. 56 is the whole, 22 is the part we know, and there's a missing part that we're trying to find out. We need to do 56, take away 22 to find that missing part. And the missing part is 34. 34 add 22 makes 56. Now that we've worked out that the star is worth 34, we can work out these other questions, because now we know two of the bits of the calculation and we've just got one missing number. But actually, these calculations follow a pattern, and as soon as you've spotted the pattern, then you can work this out really easily. The star is the same every time. We know what the star is, it's 34. And the answer, or the number on the other side of the equals sign, is only increasing by 1 every time. Which means this other part must also be increasing by 1 every time. So here are the answers. The first calculation was 22 add 34 equals 56. As the answer went up by 1, so did this part. 23 add 34 is 57. 24 add 34 is 58, and so on. How did you find that challenge? Were you able to work systematically, or did it take a bit longer as you thought about each one separately? Time to take all the things we've looked at so far and have a go in the practice book. Today you're working on page 35. Use all your determination and problem solving skills. When you're done, I've got another extension question to finish our lesson. So click pause there and have a go. Ready for an extension question? Here's today's. I think this is quite a tricky one. A green splat has covered up the ones digit in one of the parts of this part whole diagram. So you can see we've got 1 10 and some ones, but they've been covered up, and our whole is 25. The other part, that's this one here, must be greater than 10. True or false? Have a think about this question. Click pause, and when you're ready with an answer, click play. How did you find it today? Let's talk about the answer. It is, in fact, false. Let me explain to you how you can work this out. Because we don't know how many ones are here, we need to work out all the different possibilities that could be under this splat. It could be any number from 0 ones to 9 ones. Here are all the possible numbers it could be. If it was a 0, the part would be 10, all the way through to if it was 9, and the part would be 19. Time to think about what the question asked. We were told that the other part must be greater than 10, and we need to see whether this is right or not. Now, you could have written each of these calculations out systematically, and what you would have found is that the other part is not always bigger than 10. In these calculations, it is bigger than 10, but it could be smaller than 10 or equal to 10. However, you didn't have to find every possibility to be able to work this out. All you needed to do was have a go at the biggest and the smallest that the number under the splat could have been. If the number under the splat was a 0, and so the part was 10, then your other part would have been 15. 10 add 15 makes 25. So this was greater than 10. So if you'd done this, you might be thinking, okay, maybe this is true. But have a look at the other extreme. What happens if the number under the splat is the biggest number it can be, a 9, making that part 19? Well, 19 add 6 equals 25. By doing this calculation, you've worked out that the other part doesn't have to be greater than 10. So just by doing that, you've already proved that it's false. That was a tricky one today. I'd be interested to see how you found it. Well done on all your hard work. You're doing a great job problem solving and making connections between the maths that you've already learned. Let's finish our lesson there. Well done on completing another PowerMaths lesson. Miss Rachel is going to be doing the next 5 lessons with you, and then I'll join you for the very last lesson in this topic, and then to start our next topic, which will be time. Enjoy the rest of the topic. I'll see you again soon.